Hi all, here begins the second part of our fourth video in our BNB Chain development tutorial series, which is a continuation to the last video and will be the last video about introduction to the Solidity programming language. In the last video, we have discussed the state variables, functions, and function modifiers of a contract. And in this video, we will discuss special member functions in contracts, contract inheritance, and abstract contract and interfaces. First, we'll go over some special functions in contracts. The first one is the constructor function. The constructor function is the one that will be executed when the contract is created. One contract can only have one constructor function or none, so it is optional. Only one constructor is allowed, so no overloading is supported. One example is given below. Contract A has two state variable, name and owner. Constructor function takes a parameter name and sets the name accordingly. The owner is set to message.sender, which is the creator of this contract. In older version of Solidity, constructor function is declared using a function that has the same name of the contract, but in later version of Solidity, it is recommended to use constructor to declare it. Next is a fallback function. This is the default function. It will be executed whenever a function is invoked, but that function is not present inside this current contract. One contract can have at most one fallback function declared using either fallback without parameter external, you can declare it as payable or not, or fallback bytes call data input external, you can declare payable or not, returns bytes memory output, both without the function keyword. This function must have external visibility. A fallback function can be virtual, can override, and can have modifiers. Virtual and override, we're just about to talk about them when we talk about inheritance. The fallback function is executed on a call to the contract if none of the other functions match the given function signature, or if no data was supplied at all and there is no receive either function. It always receives data, but in order for it to receive either, it must be marked payable. If it is not marked payable, and then some transactions, some message calls send the ether to this contract, and none of the function appeared correct to respond for this, then it will throw an exception. Next, we will talk about receive ether function. A contract have at most one receive ether function declared using receive external payable blah blah blah, also without the function keyword. So constructor, fallback, receive either function, all of these special functions do not need a function keyword. This function cannot have arguments, cannot return anything, and must have external visibility and payable state mutability. Similar to fallback function, it can be virtue, can override, and can have modifiers. It is executed when ether was received, like say somebody execute x.send or something. Example is given here. The sync that we seen in the last video, continue to use here. And then we have a contract source which should be feeding money into sync. It has function sending, takes a parameter amount and get the address of sync and transfer to it. Note that if no receive function exists, but a payable fallback function exists, then if you send ether directly, call on a plain ether transfer, you will execute a fallback function. If none of them is present, the contract cannot receive ether through regular transaction, and they will throw an exception. However, a function without receive either function nor the payable fallback function can receive either as a recipient of a coin-based transaction, so minor block reward, or as a destination of self-destruct, So you need to pay attention to this. Then if this happens, a contract cannot react to such ether transfer and thus cannot reject them. That means these money are lost. It is just stored inside this contract. This is a design choice of EVM, and Solidity can do nothing with it. So we need to memorize this feature and avoid bug related to it. These three are important special functions for a contract, and then we can talk about inheritance. Solidity supports contract inheritance using the keyword is. You can do multiple inheritance. It will also support function override and polymorphism. In order for a function to be overridden, you need to give virtual identifier to the overridden function in the base contract and give override in the overriding function. An example is given below. Contract base function foo, virtual external view. Virtual means it can be overridden. Then in contract inherited, it redeclared function foo override the function foo. In order for somebody who inherited, who is a derived contract of inherited, to further override function foo and declared virtual here. So if in contract inherited, this function foo is not declared as virtual, then this is locked. Nobody can override that function again. We can notice that the visibility and mutability of foo changed inside the inheritance, but this change needs to follow certain rules. The visibility must be maintained unless it's changed from external to public. So either it stays the same or from external to public. The mutability can only become stricter. So if before it is view, it now can be pure. Before if it is no declaration, and that means it can be anything, it can be changed to view or pure. Note that payable is special. If it is payable, it must be maintained as payable. As we talked in the last video, function modifiers can also be inherited, and here we just give an example of this. Contract owned is the familiar one we talked in the last course, which define a modifier called only owner. Then we have a contract destructible is owned. That means it inherited from the contract owned. Then it destroy function. Then it declare function destroy. This is just the example used in the last video. I moved this destroy function down to another contract. It uses the modifier only owner. Then we have another contract called priced. That means if it can only be executed if message.value is greater than price, is sent enough money together with it. This is also an example of how modifier receive arguments. Finally, we get a huge inheritance example, the contract register. It is both priced and destructible. So as we said, multiple inheritance is possible in Solidity. It has a registered address mapping from address to Boolean. It has unsigned int price. Upon construction, it will take an unsigned int initial price and set price accordingly. Then it can do two things. One, it can register a address. In order to register that address, message.sender, somebody who want to get registered need to pay enough money. So it uses modifier costs price. What will happen here is it inherited costs from price. Then it will first check if message.value is greater than price, then this function will be executed. Registered address message.sender is true. Another function it can do is change price, and this can only be done by owner. So it uses the modifier only owner inherited from destructible, inherited from only owner, and set price to new price accordingly. note that when invoke a function, it will invoke the most derived function. It will use the function that appear in the most derived class in the derivation tree. But you can also call functions further up in the inheritance hierarchy internally by explicitly specifying the contract using contract name.function name, or using super.function name if you want to call the function one level higher up in the flattened inheritance hierarchy. That is pretty much all for inheritance. Finally, we will talk about abstract contracts and interfaces. Abstract contracts are contracts if some of the functions is not implemented. Note that if all functions are implemented, it's still possible to be marked as abstract. But if some function is not implemented, then it must be marked as abstract. These abstract contracts cannot be instantiated directly, but it will more serve as a base contract to be further inherited. One example is given below. We get an abstract contract A. It declares a function called num, but it's not implemented. Then you have a contract B, which inherited A and it implemented this function. Interface. Interfaces are very similar to abstract contracts, but they cannot have any functions implemented. Further restriction on interface is that they cannot inherit from other contracts, but they can inherit from other interfaces. All declared functions must be external in the interface, even if they are public in the contract. They cannot declare constructor, cannot declare state variables, cannot declare modifiers. So these interfaces should serve as providing interface information to the outside world. That's why it has these restrictions. A quick conclusion. We talked about special member functions, constructor, fallback, and receive ether function, and contracts. We discussed contract inheritance and function polymorphism, also function modifier polymorphism. Then we discussed abstract contract and interface. That is pretty much all for the introductory part in Solidity language. Starting from next course, we will be looking at some real-world smart contract examples so they can get a better understanding to how Solidity is working in the real world. Thank you and see you in next video.